Alright guys, welcome back. I'm going to just quickly walk you through some of the things we learned before the break, so that way you've got a video to go back to instead of me having to explain things over and over again in every class. You can kind of come back to this at your own speed. You can rewind, you can watch it as many times as you need to, you can watch it at home. So just a quick little review. First of all, make sure you have your project, your roller coaster project, and you've actually read through the instructions. And I'm just gonna make up a problem and kind of go through this really quickly. So you are getting to create your own equation. You're gonna make a roller coaster. Imagine all these graphs we were doing before the break. They all kind of had dips and curves and things, so that's like a roller coaster. Now, your roller coaster has some specifications. I'm gonna make up an equation that does not quite fit those specifications, so you can't just copy my problem, okay? So once again, do not use the equation I'm about to put on the paper. I am just making up, let's say, I'll do that. So that's a polynomial. The first thing it asks for on your rubric is the zeros. So you will most likely come up with a factored form of your equation. That's what we worked with most. That's where you can kind of easily identify your zeros. So I would recommend finding a factored form first that works for you. Okay, now your paper said you have to have at least 4 zeros. I only have 1, 2, 3 zeros. That's why, again, you cannot use this one. Okay, so finding your zeros, once you come up with the factored form that you like, remember you just take each factor and you set them equal to 0, and then you can solve for x. So on this one, I've got 0. On this one, I've got -1, and on this one, I've got +2. Now, I chose some kind of odd numbers. If you think about what this really means in real life, x-intercepts are numbers on the x-axis. Those are your solutions. Those are your zeros. So I now have these solutions. Okay, if this is real life and this is kind of like, I would assume, height, and this is like distance, horizontal distance, I have basically had my roller coaster starting backwards somehow. So keep that in mind when you're creating your zeros, that doesn't necessarily make sense. You might want to start at 0 and have everything be positive, or just come up with an explanation for why this is backwards. Maybe your roller coaster starts at a certain point and goes backwards. Like, that can be whatever you want it to be, but just keep that in mind. Okay, so you've got your zeros. It also known as roots. It's also going to ask for the multiplicity. So remember, multiplicity is where you can look back at the factored form and just ask yourself, how many times did that particular zero happen? So my x equals 0 came from this negative x. There's no squared or cubed. It's just to a power of 1. So this has a multiplicity of just 1. You have to give a multiplicity for every single root. Okay, this came from x plus 1. This, again, does not have an exponent, so it's got a multiplicity of 1. The x equals 2 came from this factor, x minus 2, and it does have a squared. So this one has a multiplicity of 2. And again, if you read your requirements, we require that at least one of your roots be what's called a double root, which means the multiplicity is 2. So you've got to have at least one of those. All right, so there's my multiplicity. Now, end behavior was a little trickier when we were in this format. So you are going to put this in standard form if you want to eventually check it later, but I'm going to go ahead and do this. We had 1, 2, 3 x's, but this last one was being squared, so really this is 1, 2, 3, 4 x's. So if remember end behavior, you were looking for if it was even or odd. In this case, I have an even number of x's. And then you were looking to see if it was positive or negative leading coefficient in the front. Mine would be negative, so my arrows are both going to be going down. So if I go over here and draw this on my graph, it would look something like that. Now here's the issue with the roller coaster project. Roller coasters are not going to go down below the earth forever. So you'll have to, again, come up with a reasonable explanation for why your end behavior is doing what you're going to do, and you'll have to create, you can make up a y number of how far down it's actually going to go. And I'll get to that in a second when I graph this, but we have your end behavior. For now, just kind of identify and think about what that's going to mean on your graph. Okay. Then it wants this factored form. Again, that would probably be where I would start with this. So you should already have a factored form. If not, make sure you've got a factored form. The next thing it asks for is standard form. This is going to be where we have to do lots of distribution to multiply this back together to make it one long string with no parentheses. So let me write this back down here. I am going to go ahead and write out my x minus 2 squared. Instead of writing it squared, I'm going to write it twice. And then you just got to do start with 2 factors and start distributing. So I'm going to start with my negative x, and I'm going to distribute that there. So that's negative x squared, and that's negative x. I'm going to put that back in parentheses because I've got more stuff to distribute. Okay, now I'm going to distribute this first parentheses to my second parentheses. So I'm going to do negative x squared times x and negative x squared times negative 2. Oops, negative times negative makes that positive. And then I'm going to also do the same thing with the negative x. Okay, and again, I'm going to put that in parentheses because I still have to distribute to the x minus 2 at the end, but I'll do that in a second. I am going to go ahead and combine like terms here to make my life a little bit easier. That'll just be 1x squared. Okay, and then you're just going to keep doing all of your distribution until eventually you get no more parentheses. So I'm just going to do this one more time with the negative x cubed. Be careful of those negatives. Then I'm going to do the same thing with the x squared. And then lastly, I'm going to do it with the 2x. And again, if you have more factors, you're probably going to have to do lots of distribution, so this is going to take a while. But when you're done, make sure you combine all your like terms. But when you're done, you should have something that looks like this, where it's in standard form, meaning, oops, those cancel out. So I actually have 0x squared, so if I really want to write that, but I'm going to go ahead and just put down the minus 4x. You should have something in standard form where it's got descending exponents. Mine's going x to the 4th, x cubed. I actually skipped x squared because like I just said they canceled out, and then I just didn't happen to have a constant term. So that would be my standard form. Now here's the thing I want you to check real quick. Go back to your end behavior. Earlier I said I had even negative. If you look here in the standard form, I have an even exponent, highest degree, and I've got a negative leading coefficient. So you can always check and make sure you got the right end behavior when you have your standard form. All right, the next thing you're going to do to check your standard form is also do some division. And before the break, we did long division and we did synthetic division. So on your project, it tells you to pick 2 different zeros or roots. I'm just going to do one with the x plus 1, and I'll do one with the x minus 2. So what you're going to do is you're going to divide that into what you just got for your standard form. And again, since I had, this is a perfect example, I had my x squareds cancel out, I am going to make sure I write in 0x squared minus 4x, and I didn't have a constant term, so I'm also going to write plus 0 there. Okay, so I'll do one long division, I'll do one synthetic, so you can just kind of get a quick reminder of all that. Long division, you're always trying to think what on top multiplied by the left side equals what's on the bottom. So what times x equals negative x to the 4th, that would be negative x cubed, and you multiply that back through both pieces of the divisor, so negative x cubed times x is negative x to the 4th minus x cubed. And then here is the tricky part. This is where you're going to subtract. Okay, so these should always cancel out. And then be careful, you're doing 3 minus a negative. So the minus the negative really makes that end up like adding. So you're doing 3 plus 1, and I have 4x cubed. And then I'm going to carry everything else down. Okay, and then I'm going to do this a little bit faster and finish this up. So again, I'm just looking for what's missing up here. I'm going to multiply it back by my divisor. At any point, if this video is not enough, you still have old notes. You've got lots of different tutorials you can find online. You really honestly should not be asking me for help until you've exhausted a few different resources. I want you guys to really try to do this on your own. So again, I'm just going to finish this up real quick. Okay, so at this point, when I subtract, those actually both cancel out, and I have a remainder of 0. We talked about before that a remainder equaling 0 means the divisor is a factor of the dividend. So that is what we were trying to prove. I was trying to prove that I did this part correctly on my previous page here. I was trying to prove that I actually multiplied this out perfectly. And so that up here, x plus 1 truly is a factor of this same format. So you, when you're doing this, should get a remainder of 0. If you don't, then either you divided wrong, or more likely, you did not multiply out correctly. So you can check yourself, since this is a test grade. If you get a remainder of 0, not 0, don't leave it like that. Go find your mistake. You've got 2 days. You want to find your mistake and fix it. Okay, now long division was probably the trickier of the two concepts, so I'm going to do the second one of these as synthetic, just as a reminder of that. So now I'm going to check my x minus 2 factor and see if it's a factor of my negative x to the 4th plus 3x cubed minus 4x that I got my standard form. Okay, so quickly, things to remember. This right here helps you get the box number, but it's always going to be like you're solving for the root. So if this was set equal to 0 and then I solved for x, it would be a positive 2, so it's always the opposite sign. And then the coefficients from your dividend is the numbers on the outside. So I've got negative 1x to the 4th, 3x cubed, 0x squared, negative 4x, 0. Okay, draw a line. You always carry down that first number, and then any bottom number you multiply with the box. You write that in the second column, and then you add the column up, and you do it all again until you're done with all the columns. So 1 times 2, add, 2 times 2, 4. Again, I'm getting, the last number is always your remainder. I got a remainder of 0, and that does tell us, again, that x minus 2 is a factor of our standard form. So I have now proven using both methods, long division and synthetic, but my 2 different factors of my 3 factors were good. So again, you have to choose 2 factors, only 2. You'll have more than 2. You have to pick 2, use one or both of these methods, and you have to prove that they work, and you're looking for that remainder of 0. All right, after that, you should be mostly done. The last thing I'm asking for is a graph. Honestly, and I'll say this in class, I might recommend starting with your graph, even just like a sketch off the side, so you have an idea of what you're starting with, and you can kind of adjust as you go, because this whole end behavior thing can be a little tricky. So I'm going to go back here. I have a 0 at negative 1, which over here is this. Multiplicity of 1 means that I'm crossing through the graph. So that's a cross through, straight through the graph. My next 0 is at literally 0, also a cross through, so that's going to go straight through. So if you think about the practicality of what's happening here, the roller coaster has now gone underground, and it's going to have to do some sort of tunneling. And then my last 0 is at 2 with a multiplicity of 2, and that's where we had our bounce, where we touched and we turned back around and bounced, and that's where it leads back up with my final arrow. Now, this is not maybe the best example for a roller coaster, because this is assuming that my roller coaster is somehow starting underground, goes up into the air, back underground, bounces at the surface of the earth, and then goes back down. Not the best roller coaster, doesn't quite make sense in real life. So this is another example of don't use this example. Make your own roller coaster. Maybe do your graph first, so you have an idea. Maybe it should look more like this, where it starts at the ground, goes up, tunnels below, goes up, does this. However you want your roller coaster to look, but it needs to be somewhat practical. Okay, but you can still graph it using all the things we talked about. And then the last thing I asked for is the domain and range of your graph, and this is again where these arrows don't quite make sense, so I'm going to just close this off right there at negative 3. Same thing right there. Instead of doing an arrow, right? Roller coasters don't go on forever and ever and ever. They have stopping and starting points. So you're going to want an actual practical graph. And then your domain. Remember, domain is always left to right. So you would look at how far left is this going? What's the x value? And then you look at how far right is it going? What's the x value? And you would do your domain. Okay, for range, you're always doing bottom to top. So you look at how far down does your graph go, look at that y value, and then look at that up, how far up does your graph go, what is that y value, and give me that domain. Okay, but when it asks on the rubric for the practical domain and range, that means it cannot be infinity, right? Roller coasters do not go forever in any direction. They've got starting and stopping points, left, right, bottom, and top. So make your graph make practical sense, and then have that reflected in your domain and range. All right, if you have any other questions, make sure you're, again, using your resources, and you're coming to me only when absolutely necessary. All right, good luck.